Good morning, good afternoon, everyone. I'm Ayu Widya Utami. I'm a student of School of Environmental Science, Universitas Indonesia. Now, I want to presenting my paper entitled Water Quality Assessment of West Tarum Canal for Drinking Water Supply. This is outlines of this paper. Introduction. Start from access to safe drinking water is a human right and is a fundamental necessity for humans to live. However, more than 2 billion people in the world do not have access to safe drinking water. Fresh water is the most widely used water resource for various kinds of human life needs, one of which is drinking water. Fresh water consists of groundwater and surface water with a percentage of fresh water on Earth around 2%. Groundwater is still the most widely used source of water to meet drinking water needs. However, in the last few decades, increasing demand for water and groundwater over exploitation has led to land subsidence. Surface water also has problems, such as water pollution. Water pollution often occurs in surface water because of the important role it plays as a transportation route for the disposal of domestic and industrial waste and runoff from agriculture. Almost 59% of rivers in Indonesia are categorized as heavily polluted. This water pollution causes many Indonesians to experience a shortage of clean and drinking water with a total population of nearly 28 million people affected. The West Tarum Canal, or WTC, is one of the surface water used as a source of raw water for drinking water for Jakarta people. Nearly 81% of the raw water for drinking water for the Jakarta people comes from this canal. Water pollution of WTC will be a threat to the availability of drinking water supply for Jakarta people and can also be burdensome for the drinking water treatment process that will be carried out. Also, if the water quality of WTC worsen, it will cause an increase in water tariff due to increasing production costs, which will then impact people's ability to pay drinking water. Thus, water quality is one of the important points that can affect the supply of drinking water. Based on this paper aims to assess the water quality of the West Tarum Canal. This is method of this paper. First, water quality monitoring points. The selection of WTC water quality monitoring points in this paper is based on the sampling points used by Perum Jasa Tirta II with 10 sampling points. Then, water quality assessment. Water quality data for the WTC from 2016 to 2020 were obtained from Perum Jasa Tirta II with parameters in the form of TDS, pH, DO, BOD, COD, iron, and manganese. The first method is comparing water quality with the Class 1 of Water Quality Standards based on Republic of Indonesia Government Regulation Number 82 of 2001 concerning water quality management and water pollution control. The standard can be seen on Table 1 on the right side. Then the second one is using storage method. These steps are: first, collect the time series data of water quality. Second, compare the water quality data with the water quality standards. Third, if the water quality data compatible with the standards, the score is 0. Fourth, if the water quality data exceeds the standards, the score based on table 2. Fifth, calculate the storage score, then decided the classification of the water quality status based on table 3. Result and discussion. TDS concentration in WTC range between 142 to 351 milligrams per liter, which indicates that the TDS concentration is still meet the water quality standards. The highest average of TDS concentration was at monitoring point 4, with the concentration is 217 milligrams per liter. This is due to the input from other surface water with a high TDS concentration. At that point, there are several illegal settlements, small and medium enterprises that contribute to increasing the TDS concentration in WTC. The pH value in WTC range between 5.75 to 7.68, which indicates that almost all WTC monitoring points have pH value that meet the water quality standards. A very low pH causes metal solubility in the water to increase, which is toxic to aquatic organisms. On the other hand, high pH can increase the concentration of ammonia in water, which is also toxic to aquatic organisms. the DO concentration in WTC with a range of 3.6 to 4.9 milligrams per liter, BOD with a range of 4 to 10 milligrams per liter, and COD with a range of 13 to 30 milligrams per liter, which indicate that three parameters do not meet the water quality standards. Increasing BOD and COD will reduce the DO concentration in the water. DO acts as an important indicator of water quality that can be used to assess water health, while BOD and COD are considered indicators of pollution in water. Domestic and urban activities caused the high concentration of BOD and COD in the WTC. In addition, the presence of inflows from other surface water contributed to an increase in BOD and COD concentration in WTC. Iron and manganese are naturally contained in water but at a relatively small concentration. High concentration of iron and manganese in water are usually caused by anthropogenic activities around water bodies. The concentration of iron and manganese in the WTC range from 0.1 to 0.15 milligrams per liter and 0.03 to 0.1 milligrams per liter, respectively. The highest concentration of iron and manganese are in the upstream of the WTC between monitoring points 2 to 4, while the downstream tends to be smaller. This is because there are still many activities in the upstream to dispose of domestic waste, both liquid and solid waste, which are disposed directly into water bodies. The increase in iron and manganese in water used as a source of raw water for drinking water will cause problems such as corrosion of pipes and accumulation of sediment in drinking water distribution systems. Based on storage method, the water quality of WTC ranged from -26 to -38 with an average of -30, which indicates that the water quality of WTC has been moderately polluted. In the upstream of WTC, many illegal settlements do not have private washrooms in their houses, so bathing and washing activities are carried out directly in the WTC's water bodies. Also, runoff from agriculture and solid waste in water bodies and around the upstream banks of the WTC contribute to water pollution that occurs. In the middle streams of WTC, the source of pollution is dominated by settlements, agriculture, and small and medium enterprises. Also the entry and mixing of other surface water, namely the Cikarang River, which has poor water quality, causes the decline of WTC's water quality and it becomes polluted. Meanwhile, at the downstream of WTC, infrastructure development activities around the canal contribute to water pollution. Conclusion. First, the parameters of TDS, iron and manganese in the West Tarum Canal are still meet the Class 1 of water quality standard based on Republic of Indonesia Government Regulation Number 82 of 2001, while DOBOD and COD do not meet the standards. At almost all monitoring points, the pH value meet the standards. Based on storage method, WTC's water quality has been moderately polluted with an average storage score of -30. As a source of raw water for drinking water, water contamination in WTC will aggravate the drinking water treatment process that will be carried out and can increase drinking water tariff due to increased water treatment production cost. Increasing the drinking water tariff will have an impact on people's ability to pay for drinking water. Therefore, WTC's integrated management is needed from upstream to downstream, and it's necessary to increase collaboration between stakeholders in carrying out this management. This is references that I used in this paper. Then, thank you.